In this lecture, I am going to discuss static class members. See, static class members, we can have them in two categories. The first one is static class data, and another is static class functions. Static class data and static class functions. See, guys, actually, what happens is, as we people know, that we have as many copies of instance variables as the number of objects, right? But as far as static class data is concerned, we will be having only one single copy of static class data, irrespective of number of objects that we have for our class. Say, if there is a class, and it has got 100 objects, any n number of objects. So, as far as instance variables are concerned, we will be having as many copies of instance variables as the number of objects. But static class data is concerned, as far as static class data is concerned, we will be having only and only one single copy, and that will be shared by all the objects of this class, right? So, as far as static class functions are concerned, static class functions are those functions in which we have written all the statements which are in the context of only and only static class variables, static class data. In static class functions, we cannot manipulate with, we cannot access the instance variables, right? So, static class data can also be referred to as non-instance variables. Non-instance variables. So, we will be saying, I will be giving you an example, a real life example of say static class data. Suppose we have got a class, and that class belongs to the students of a particular college, say ABC college. See, now we will be having certain instance variables like university registration number, roll number, then name of the student, father's name, right, cell number, etc. All of you can judge that all these are instance variables, and we will be having as many copies of these instance variables as the number of students in that class. So, number of students, they correspond to the objects of the class, right? Now, apart from this, suppose our intention is to have the name of the college also, and suppose the name of the college happens to be DAV College. Now, it will be utter wastage of memory if we people declare a string variable called college name. What will happen in that case is, we will be having if there are going to be 60 students, that means 60 objects of the class, we will be having 60 copies of the string variable college name. So that is sheer wastage of memory. Why? Because there was no need to have so many copies of the college name, because all the students, that is all the objects, they were sharing the same college name, that was DAV College. So as far as the string variable college name was concerned, there wasn't any need to declare it as an instance variable. It would have been a very good programming practice to have only one single copy of this college name. So if I declare it as a static class variable, it will be having only one single copy, and this will be shared by all the objects, that is in this example, all the students of the same class. Now I will be giving you a practical example, and would you please pan the camera on the projector? See, guys, I have written this program using dev C++. You can see carefully. The name of the class is sales. What I want to do is, I want to have three instance variables. SNO is for salesman number, SMT is for sales amount, com is for commission, and apart from these three instance variables, I have declared a static class variable called .com. You can clearly see I have used the C++ keyword static that is preceding the declaration float .com, right? So now we come to the functions, and in function parts, see, we have got a member function called RD. This function is being used to read the values into salesman number, sales amount and commission. And see, we are getting the total of the commissions, and that is being put into the into the static class variable .com. Another function is avg_com. Now this function avg_com is supposed to display the average commission. You can clearly see that this function avg_com is printing the total commission, that is .com, which happens to be our static class variable. At the same time, we are getting the average commission printed on the screen. See, listen this carefully. A static class function can access only and only static class variables. It is not allowed to access the instance variables. It is not allowed to access the instance variables. Now see, you will see another syntax, that is the syntax of declaring a static class variable. Once I have finished the class, after this I have declared my static class variable, the syntax goes like this. First we are supposed to give the data type, then name of the class, scope resolution operator, followed by the name of the static class variable, assignment operator, and whatever value you want to initialize it with. In this example, I am supposed to initialize my static class variable .com with the value 0. So float sales scope resolution operator .com 0.0. This is the declaration of static class variable. Now we come to the function main. See, in function main, what I have done is I have declared three objects belonging to the class sales. Sales SOBJ1, SOBJ2, SOBJ3. So there are three objects of this class. All these three objects, they will be comprising SNO, SMT and COM. So there will be three copies of each instance variable, and afterwards SOBJ1.rd, that is going to invoke the function RD, SOBJ2.rd, again the function RD is being invoked, but this time over the current object happens to be SOBJ2, SOBJ3.rd. As you have seen previously, the RD function is supposed to read the values of instance variables of our objects. So we have put the values into SNO, SMT and COM of the object SOBJ1. Similarly, we have assigned the values into SOBJ2 and SOBJ3. We have got the values into all these three objects. Now, what is our next objective? We want to display the average commission. As you have seen in the above class, I have written a static class function called avg_com, right? So, see the syntax of calling a static class function. It goes like this: class name followed by scope resolution operator followed by the function call. So sales scope resolution operator avg_com. So what I would say is, here I am calling the function avg_com, rather static, I should say static class function, and it is being qualified not with the name of any object, but it is being qualified with the name of the class. So in the sales scope resolution avg_com call, the control will go into avg_com and it is going to display the average commission. Now guys, see, I want to explain a particular point, and that point is, a non-static function. In this case, the non-static function that happened to be RD. In a non-static function, it can access both. It can access both instance variables as well as static class variables. Here you can clearly see I have accessed SNO SMT com. It's no bigger deal because any non-static function that is free to access all the instance variables of the class. But as far as .com is concerned, as you have noticed, .com is not an instance variable, rather it is a static class variable. It will be having one single copy. It will be having one single copy in the memory. So .com plus is equal to com. By doing this, when I have called this function sobj1.rd, the control will come into this particular function rd. The values will be put SNO, SMT, com. They will be read from the user, and .com will be assigned. The .com will be assigned the value of it will be assigned the value of com, because at the very first time the value of .com is 0, as I have initialized it in the end of the class. So value of .com would be .com plus is equal to com, that is going to accumulate all the commissions of the objects, namely SOBJ1, SOBJ2 and SOBJ3. So guys, you will have to keep this thing in mind. A non-static function is free to access both instance variables as well as static class variables. But as far as static class function is concerned, it cannot access instance variables. So next time we will be discussing another topic of C++. For the time being, thanks.